So dear students, today we are going to discuss extrinsic semiconductor. We have discussed intrinsic semiconductor, the pure semiconducting materials. Extrinsic semiconductor, those materials or substances which have some other impurity atoms mixed with them to increase their conductivity. As we know, as the temperature is raised for a semiconductor substance, its conductivity increases. But a pure semiconductor material has its own limitations. So for the same increment in temperature and to get the better conductivity, we use or add some impurities or some other materials as impurities in the intrinsic semiconductors. And now these intrinsic semiconductor with mixed impurities are called extrinsic semiconductor materials. A few part of a suitable impurity. A few part per million. Is added to pure semiconducting materials. To increase its conductivity, manifolds. Such type of impurity added semiconductors are known as extrinsic semiconductors or impure semiconductors. The impurity added in desirable amount are called dopants, and the process of impurity addition is called doping. Thus, the impure semiconducting material is also called doped semiconducting material. There are two types of dopants. First, pentavalent, having their valency 5, their valency plus 5. They can contribute 5 outermost orbital electrons for the bond formation with other atoms. Example, arsenic, antimony, phosphorus. The second type of impurity that can be added, trivalent. Its valency plus 3. It can contribute only 3 electrons per atom for bond formation between two atoms. The example of trivalent impurities, indium, boron, aluminium. Now we will discuss how the doped amount of impurities changes the conductivity of a semiconducting material. Silicon or germanium, the pure semiconducting materials, are mixed with these impurities, or you can see these impurities are added to some extent in pure silicon or germanium semiconducting materials. So according to impurities added to the pure semiconducting materials, The impure semiconductors or the doped semiconductors are of two types. Doped semiconductors are of two types. First is N-type semiconductors and second is P-type semiconductors. So first we are going to discuss N-type semiconductor material. As we know, in N-type semiconductors, a pentavalent impurity is added, a few part per million. The impurity of pentavalent material is added to pure germanium or silicon substance. The pentavalent atom has 5 electrons to contribute for bond formation, and germanium or silicon, the pure semiconducting material, their atoms have 4 electrons each to contribute those for the bond formation. It means when there is a bond formation between an atom of germanium and the impurity atom, one atom of the pentavalent impurity will make 4 bonds, covalent bonds with the 4 germanium or silicon atoms in which it is added. There will be one electron which is the free electron remaining, which does not take participation in bond formation, and it is free to move in the conduction band of the pentavalent atom. It means whatever the amount of impurity is added, the pentavalent impurities atoms are the donor atoms which will provide the extra free electrons. 4 electrons of pentavalent atom are there to contribute in bond formation between one pentavalent atom and 4 germanium. Say we are taking the germanium. Thus, 4 electrons participate themselves for bond formation, and one of electron provided by pentavalent atom is free to move in conduction band. So the dopant, which is a pentavalent impurity, is called donor atom or donor impurity. The number of donated electrons depends upon doping level. Independent from any increase in ambient temperature. So in a doped N-type semiconductor, concentration of electrons Ne depends upon both donor and intrinsic materials, while concentration of holes and H is the contribution only by intrinsic material. Also the rate of recombination of electron and hole increases, and as a consequence, number of holes reduces further. So here the concentration of electron is very much greater than concentration of holes in n-type semiconducting material. That's why they are known as n-type semiconductors. That's all for today. We will discuss the p-type semiconductor in our next lecture.